for number 1 in your notes, you are given points A, which is at 2, 5, and point B, which is at -4, -3. Okay. First step, plot those points. So 2, 5, and -4, 3, -3. Okay. We're going to connect those points. Then we're going to see how far we went down and over. When we do this, we're going to kind of make a right triangle. Okay. So if you count from this point to our new point, and we're going to call this new point right here where these two lines touch, where they meet, C. Again, this is A, this is B, and this new point is C. We went down 7. Okay. Sorry, we went down not 7, 8. When you count, you should have gotten down 8. And then we went over to the left 6. Okay. Well, we want to figure out what AB is, what this is right here. We want to figure that out. Well, if you can remember back, we can use the Pythagorean theorem, which is A squared plus B squared equals C squared. Okay. Remember, C is the hypotenuse. So we know one of our legs and we know the other leg, and we can plug that in for A and B. Okay, so we have 8 squared plus 6 squared equals C squared. Okay, our hypotenuse, this is C. Well, 8 squared is 64, 6 squared is 36, 64 plus 36 is 100. Okay. And all you have to do, take the square root of both sides, and the square root of 100 is 10. So AB, the length of AB, is 10. And there you go. You can use the Pythagorean theorem, okay, when you're trying to find the distance between 2 points, but sometimes it might not be very convenient to graph, like you're dealing with really big numbers that don't necessarily fit on a coordinate plane. Okay, you can use the distance formula, which is D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So if you look at number 3 in this section of your notes, do number 3 together, you're given that x is 7, -2, and y is -3, 3. Okay. Well, first I like to label that this is my first x, so it's my x1. This is my first y, so it's my y1. Second x, second y. And then all you have to do is just take those numbers and plug them into that formula. So we end up getting our y2 minus our y1 squared, our x2 minus our x1 squared, plus our y2 minus our y1 squared. And you can just plug this into your calculator. Okay? You do -3 minus 7 and then square it. And then 3 minus -2 and then square it, and then add that together. When you do that work, you should get 125 underneath your radical. Okay? And it's really important that if you can simplify the radical, do so. So we talked about this in our Algebra 1 skills review. You're going to find the largest perfect square that can go into 125. The largest perfect square that can go to 125 is 25, and it can go in 5 times. When you simplify, the square root of 25 is 5. Can't take the square root of 5, so we just tack it on at the end. So your answer is 5 radical 5. And if we round, if we were trying to find the length of something that we were trying to paint, you wouldn't necessarily say that, oh, the room is 5 radical 5 feet squared or something like that, or 5 radical 5 feet. I would just plug in your calculator and round. You should get about 11.2. There you go. There's your final answer.